so now we're going to talk about geometric probability. And I know you did some probability at Berry if you came from Berry or in middle school because that is a big concept for the pre-algebra. So we're going to have to tap into some of that and talk about probability when in a geometric sense. So if you remember your basic probability definition, the probability is the number of favorable outcomes over the number of possible outcomes, okay? For instance, if I'm flipping a coin and I want to know what the probability that when I flip that coin I get heads, then I would say, okay, that's 1 out of 2 because heads is one of the options of 2, heads or tails, correct? So that's basically your probability ratio, okay? In geometric probability, points on a segment or in a region of a plane represent outcomes. The geometric probability of an event is a ratio that involves geometric measures such as length or area. Okay, so that's the basic overview of geometric probability. Okay, so the first one we talk about, the probability here, this example says a point S lies on the segment AD. Yeah, so somewhere on that segment. Okay, what's the probability that S is between B and C? Okay, do you see that? So basically would say, well, there's 3 sections, A to B, B to C, C to D, right? And BC is one of what? 3 sections, right? And so that's one of the ways that you would find your probability. Yeah? Let's do some examples with numbers, okay? If we look at this one right here, it tells us that point K is on the line ST, yes? What is the probability that K lies between QR, okay? Well, the way we're going to do that is we're going to say the probability of, okay, and you're going to say the absolute value, right, of QR over the absolute value of what? ST, right? So, how does that work? ST, the absolute value is what? 2 to 14. So we'd say 2 minus what? 14. QR is 5 to 8. So we'd say the absolute value of 5 minus 8. Why am I using absolute value? Right, we're just talking about distance. We don't want any negative measures, okay? So then once I subtract this, the probability, 5 minus 8 gives me what? Negative 3, absolute value is 3. 2 minus 14 is negative 12. Absolute value is what? 12. Okay, can I reduce this? Yes, I can. So I do want to simplify. 3 over 12 becomes what? 1/4. So the probability that K lies between QR, so the P of QR, right, is what? 1 out of 4. Could you do that one? All right, let's talk about the probability that a commuter waits at least 10 minutes. In this particular problem, we're talking about a commuter train that runs every 25 minutes. So the length of my segment that I'm talking about is from 0 to 25. Okay? We want to know the probability that the commuter waits at least 10 minutes. So I'm going to go to about where 10 minutes is just to kind of have a representation of what I'm talking about. That's 10. Now, am I looking for the probability from 0 to 10 minutes or from 10 minutes to 25 minutes? My commuter needs to wait at least 10 minutes. So 10 would be what? The least. So I'm looking for the region that goes from 10 to what? 25. So my favorable segment is going to be the absolute value of 10 minus 25, right, over what? The entire time, which is what? 0 minus 25. Get 15 over 25. That also can be simplified to what? 3 out of 5. Good. So the probability that I wait at least 10 minutes, right, is what? 3 out of 5. If we talk about the same commuter train, we want to know what's the probability that the commuter waits only 5 minutes, okay? So my time limit is still 0 to what? 25, okay? My marker is at 5. Are we looking for the time between 0 and 5 or between 5 and 25? 0 and 5, because now it's asking what happens if I wait no more than 5 minutes, right? So now 5 is going to be the top. So I'm going to do the same thing. So my probability is going to be equal to the absolute value of 0 minus 5 over the absolute value of 0 minus 25. So it's 5 over 25. Can that be reduced? 1 out of 5. Good. So the probability that I wait no more than 5 minutes is what? 1 out of 5. Okay. What are the key words that I was looking for? No more than, right? And what? At least, right? Okay. The next one we're going to do has to do with area. Here's our key concept picture. Tells us that S is in the region, right? It's in R, within the plane R or the figure R. What's the probability that it's within N as well? You do that by finding the area of N and dividing it by the area of R, okay? We're going to do it with this square. We have point Q, and we want to know what is the probability that Q is in the shaded region. We know that Q is within the square. What's the probability that it is in the shaded region within the square? Okay. Now, for our plan, what do we need to do? I need to find the area of what? I need area of the square. I need what? Area of the circle, right? Okay. What's the area of the square? One side is 6. It's a square, so what are all the sides? They're all going to be 6. So the area of the square is going to be equal to 6 times 6, which is going to be 36. Okay? Now I need to find the area of the circle. Okay? Now, if this right here is 6, right? It's 6 all the way across, isn't it? Which makes the diameter of the circle what? 6. Okay? Uh-oh. That's not what I wanted to move. And if the diameter is 6, what's the radius? 3, okay? So this is going to be 3. So the area of the circle is going to be pi r squared, which is pi 3 squared. So that's going to give us what? 9 pi, okay? Now, in order to find the area of the shaded region, what must I do? Subtract. So I want to say area of the square minus area of what? The circle, right? So that's going to be 36 minus. Now at this point I am going to have to multiply by pi, right? So that I can combine these. I got 28.27. .7. It's like 7.73. Okay, and again, this is still centimeters squared, right? Now, one more step. I still need to find the probability. By finding the probability, I'm going to need to divide the area of the shaded region by the entire area, which is the area of the square. So I'm going to say 7.73 over what? 36. Very good. Now, we have been so far putting our probability in ratios or fractions. Is this one going to be best in fraction? No, it's not. It's not going to be a pretty fraction at all. However, probability is not supposed to be in decimal. So I got 0.2147. So I can't use that. What form could I put it in, though, that would be acceptable? Percentage. Perfect. Yes. So I'm going to take this and I'm going to say, okay, well, that's about 21.5%. And that is an acceptable format for probability. Okay. We have 4 practice problems right here. So I'm going to pause and let you go ahead and do the practice problems, and then we'll check them. Okay, so you can check your answers for 17, 18, and 19 and 20. Remember that probability could be in a ratio or a percentage, but we don't want to use a decimal. So if you notice in number 18 and number 20, the ratio was not a real friendly number. So I went ahead and changed that to a percentage. Okay.